guys, this is just a quick tutorial on labeling the brain because I notice it's not on my presentation. So you can see here, the whole top area collectively is called your cerebrum. The front area here is called your frontal lobe. And it does say that in my presentation about the main functions. The middle top area is called your parietal lobe. Back area here is called your occipital lobe. Now under here is your cerebellum. And here is your temporal lobe. So you can pause this and fill out your workbooks. This here then, you want to mainly, the cerebrum's the same. This is your thalamus. Your thalamus is basically a gateway between your endocrine system and your central nervous system. Here is a little triangle and it's called your hypothalamus. It's underneath the thalamus. You do not have to label this little unit here, which is called your pituitary gland, but it's just good to know where it is. All right, in your brain stem, which is still part of your central nervous system, you have your midbrain right up into the base of the skull, brain. You have your pons area here, and you have your medulla oblongata here. And you might remember medulla oblongata when we talked about the respiratory system. And we said if someone was to hold their breath, they get forced to breathe because the medulla oblongata will pick up that there's no oxygen. It's been told from the nerve receptors in the aorta that there's not enough oxygen and too much CO2. This sends a signal to the medulla oblongata. The medulla oblongata sends signals to all your breathing respiratory muscles to make them contract and breathe. So that's labeling the brain. Pause and go back if you want to. Okay, now I'm just going to talk about the transmission of a nerve impulse. Okay, let's quickly get a color, say like orange. All right, I'm going to draw the dendrites. These are the dendrites. The dendrites receive information and carry information afferently to the cell body. This is the cell body. Now we're going to draw the axon. This is the axon where the messages goes down, and at the bottom of the axon are axon terminals. And in these axon terminals, sit vesicles, and in these vesicles are all neurotransmitters. And little bubbles are lots of little chemicals called neurotransmitters that want to get out of the axon terminal and send a message to the next effector. Okay, so this is how it works. There are two major ions, sodium and potassium. When it's resting, potassium is mainly the majority of potassium sits inside the cell. Potassium is the K. And this one is resting, and sodium sits outside mainly. There is a little bit of a crossover, but not much, okay? So sodium sits outside. So this is just a real brief explanation, and don't think you'll be asked it, but it's just good to know how these chemicals work. Okay, so the dendrites receive a stimulus. The dendrites carry this stimulus down to the cell body. When it gets to the cell body, it gets enough stimulus, the cell body has to react. And what happens is channels open, so potassium will get out and sodium will get in. More and more sodium will get into the cell, which will make this neuron activate. Okay, it's now buzzing. It's got enough energy to produce a nerve impulse. The nerve impulse then has to travel down the axon. So down this axon, there is still gates opening. There's still channels opening where sodium is getting in and the potassium is coming out. So there's lots of gates. There's lots of going in. It's like a cascade effect, Sodium is getting in, potassium is getting out. When that electrical charge of all this positivity has got down to the axon terminals, that's when gates will open here and all the neurotransmitters will be released and they'll swim across the synapse. Remember, the axon terminals never actually touch the next organ, whether it be a muscle, whether it be another neuron. There's always this gap, and this gap is called a synapse. So when the neuron is resting, there is potassium on the inside, sodium on the outside. When the dendrites has received a stimulus, and these dendrites could be in the peripheral nervous system, they've received a sensation, they carry a message afferently towards the cell body of the neuron. The cell body gets this message and channel will open up so sodium can get into the cell body. When sodium is in the cell body, it makes that neuron positive and it wants to send a signal down the axon terminal. It's called an action potential. This signal starts to transfer down the axon, and as it goes, the more sodium that gets in, the faster this signal will travel down the axon, gets down to the axon terminal, and it's almost like it kicks these vesicles further. These vesicles get to be released, and all the neurotransmitters swim across the synapse to go and send the message. The message might be to another neuron to send the message again, or it could be to a muscle to make it contract. There is a YouTube clip that I want to show you that you can look on the presentation where it has this transmission for you. Hope this makes sense, guys.